Okay, now let's do, this is one just like that, that's just like on your field theory worksheet. So we're going to move a charge from G to H. So it's going to go from here to here. And it doesn't really matter how we move it, okay? But this is our initial. This is our final. Okay? And what we're going to do is we're going to find the voltage here. We're going to find the voltage there. We're going to go final minus initial, and then we're going to multiply. Then we're going to multiply by the moved charge. Okay, we're going to move that charge, this plus 3.4 microcoulombs from here to there. So our first step is finding the voltage at G, which we think is that, right? Okay, so the voltage at G is just simply going to be the voltage of A plus the voltage of B, right? Okay, so, and it's a simple scalar sum. So the voltage at A is 8.99 E9. The voltage due to A, sorry. The voltage due to A is 8.99 E9. A is negative 14.7 E minus 6. And then the distance to G from A is, this is 1 and that's 2. So it's a square root of 1 squared plus 2 squared, right? And then the voltage due to B at G, right? The voltage due to B is 8.99 E9 times, and then B is positive 17.2 E minus 6. You have to put the minuses and the positives in there, right? And then this distance is 1 over, and let's see, 1, 2, 3, 4, 5 up. Right, so that's the square root of 1 squared plus 5 squared. So let's try that. Okay. So let's go negative 14.7 E minus 6 divided by, okay, square root of, left parenthesis, 1 squared plus 2 squared. Okay, and then let's see. And then the second one is 8.99 times 17.2. 17.2 E minus 6, right, divided by the square root of left parenthesis 1 squared plus 5 squared, 1 squared plus 5 squared. Ta-da. I'm going to store that in G. All right. I am getting negative 28,775.57, right? So I'm willing to go with this number. So that's step one. Holy cow, you'd think we'd be done with this problem, but we're not. Okay, step two is to find the voltage here. That's the final voltage, right? So step two, find the voltage at H. And it should be 13,573.1. So let's do that. The voltage at H is equal to the voltage due to A plus the voltage due to B at H, right? So the voltage at H equals 8.99 E9 times A. Let's see, A would be negative 14.7. And then, oh my gosh, A. Let's figure it out. A is 1, 2, 3 down, right? And 1, 2, 3, 4, 5, 6, 7 over. Let's double check. 3 down. 1, 2, 3, 4, 5, 6, 7. Yes, so square root of 3 squared plus 7 squared, right? And then the voltage due to B is going to be 8.99. All right. You are truly an exceptional student if you are listening to this video. It's going to be the most boring video in the entire world. Okay, hold on, stop. All right, the voltage due to B will be is straight over. So let's see, it's 1, 2, 3, 4, 5, just 5. That's easy. Well, like that. All right. Okay. I'm going to store this in H. Okay, so here we go. 14.7, 8.99. Okay, and then these distances are 3 and 7. So 3 and 7. And then this guy is 17.2, but it's just over 5. So I'm going to say it's 0 down and 5 over. Is that right? Yeah. Are we ready? Okay. Are we ready for this excellence? Okay. The answer is positive 13,573.1. I get 0.06 is what I get. So I'm willing to buy this answer, right? So that's step 2. You'd think you'd be done with the problem by now, right? Okay, well, let's do steps 3 and 4, which is find the work done. Okay, to find the work done, what we're going to do is we are going to find the change in voltage, which is the final voltage minus the initial voltage, right? And since we are going from G to H, this is the final, this is the initial. Initial, how do you spell initial? This is the first one. Okay, let's see. The final voltage is this guy, right? So the delta V is 13,573.1, right? Minus the, the final, right, is this guy, right? Minus the initial, which is minus negative 28,775.6 is equal to, okay, so alpha H, whoops, I really need to turn on the lights here. Alpha H, yes, alpha G, I stored these numbers, so alpha H minus alpha G. Okay, if I do that, I get a whopping 42,348.6 volts. And then the final thing is that work is change in voltage times moved charge. So we are moving this charge, right? So I'm going to say that it's 42,000, right? And that's joules per coulomb, right? Times 3.40 E minus 6 coulombs. Okay, so I'm just simply going to multiply this times 3.4. And I get, after all that work, that hardly seems worth it, I get 0.14398. If I wouldn't be so bad, it would be terrible if I got the wrong answer at this point. But that's what I got before. That's got to be the right answer. Yay! Holy cow, you are such a good student if you're watching this.